My problem is from section 11.2, number 17a. It asks to find the minimum polynomial of the given element over q of square root of 1 plus square root of 5. So first I let alpha equal this element over q. Then I squared both sides so we can get rid of this main big square root. From there I subtracted 1 so that it's alpha squared minus 1 equals square root of 5. And then I squared it again, squared both sides again, to get rid of the square root over the 5. So then we have alpha squared minus 1, quantity squared equals 5. The next thing I did was expand this. This is kind of my scratch work over here, but you can expand it however you want. And I got alpha to the 4th minus 2 alpha squared plus 1 equals 5. And then I subtracted the 5 over to get alpha to the 4th minus 2 alpha squared minus 4 equals 0. So now this would be our minimum polynomial, but we just replace the alphas with x's. So the minimum polynomial would be f of x equals x to the 4th minus 2x squared minus 4 if it follows those three conditions. So we have to check that f of x equals 0, that f of x is monic, and that f of x is irreducible over q. If you plug in our given element into this polynomial we found, we do see that it equals 0, so it does follow this first condition. F of x is monic since the coefficient in front of the x is just a 1. And then the last thing we have to check is that f of x is irreducible over q. So what I did was I took the polynomial that we found, and in mod 3, this is what we end up getting. So I just called it h of x so I don't get confused. H of x equals x to the 4th plus x squared plus 2, and that's this polynomial mod 3. So first I want to check that there are no linear factors. So I plugged in h of 0, h of 1, and h of 2, which none of them end up being roots, so we have no linear factors. The next thing we have to check is if it has any monic irreducible quadratic factors. There are 3 monic irreducible polynomials of degree 2 over z3, and those are these polynomials right here. So what I did was I double checked to see if these were factors of our h of x polynomial, and since we got remainders with all 3 of the monic irreducible polynomials over z3, that means that there are no quadratic factors. If there was a factor, we would have gotten a 0 as a remainder. So, since there aren't any linear factors or quadratic factors, we know that f of x equals x squared minus 2x squared minus 4 is irreducible over q. So that f of x equals x to the 4th minus 2x squared minus 4 is the minimum polynomial of our given element.